Okay, so in this question, we've been given, well, in this reaction, effectively what you can see is that NH3 is reacting with oxygen and it forms nitric oxide and H2O. And we've been asked to figure out, well, what's the volume that NO that's produced, what's it going to occupy? Okay, so how am I going to go about figuring this out? Well, one of the things I'm going to need to work out is the number of moles of NO, right? That's going to be one of the, one of the important steps I need to be able to get to be able to then figure out what the actual volume occupied is. And when I look at the data I've actually been given in the question, I've been told that the mass of NH3 that reacts is 46.34 grams. And I've been told that the oxygen is in excess. Now, what that effectively tells me is that the limiting reagent in this reaction is going to be the NH3. It's not going to be the oxygen. So what that effectively means is the main thing that's going to determine the amount of NO produced is the mass of NH3. So I can effectively use that information to say, okay, well, I can then use the balance equation to work out the moles of NO. So let's work step by step through that process. So the equation I'm going to be using is the fact that the mass is equal to the number of moles multiplied by the molar mass, MR, right? Specifically, when we divide both sides by the MR, right, the molar mass, and this would cancel, of course, we get the equation that the number of moles is equal to the mass divided by the molar mass, right? In this particular context, within the context of NH3, we have the mass. We've been given that in the question. Now the MR, we've not been given it in the question. However, we have been told what the formula is of the ammonia, NH3. And so we need to work that out in order to actually work out the moles of the ammonia. So we're going to do that. So MR of NH3 is going to be equal to what? Well, we're going to need to get the relative atomic mass of the nitrogen, right? So is going to be 14, and the relative atomic mass of hydrogen is 1. So what we're going to do is going to get 14 multiplied by 1, and we're going to add this to H3, so that's going to be 1 multiplied by 3, okay? And effectively, if we go through that process, it's going to give us 17, right? And the units, given it's a molar mass, is going to be grams per mole, okay? Now, the other thing here, which needs to be considered is, okay, well, let's put the equation together, right? So let's plug this in. So it's going to be 46.34 divided by the 17, right? And so if you have a go, work out what that would be. This is going to give the number of moles for the NH3, okay? So if you work that out, that is going to give 2.7258824, right? And that's going to be in moles. Now, beyond that, we need to actually compare in terms of the actual equation. So this equation, we need to look at, well, for any given number of moles of NH3, what is going to be the number of moles of NO produced, right? And what this balance equation tells us is that for every 4 moles of NH3, 4 moles of NO is produced. And so if we set this up as almost like a ratio, right, and we can say that the number of moles of NH3 as a ratio of the number of moles of NO right? For every 4 on this side, we're going to have 4 on this side, right? And if we divide both sides by 4, you know, to keep it balanced, to get it down to 1, we get 1 on both sides. And that tells us that the number of moles of NH3 in this particular equation is actually going to be equal to the number of moles of NO, right? Now with this information, what can we say? Well, what we can say is that the number of moles remember this value here is the number of moles of NH3. We can say therefore that the number of moles of NO is equal to the value we got, so 2.72588824 moles. So we can say this, and if we refer to in terms of the relationship between the moles and the volume, right? 1 mole of any gas occupies a volume of 24 decimeters cubed at room temperature and pressure. And we've been asked in this question to calculate the volume occupied at room temperature and pressure. So we can say, well, actually, for every mole of NO that we have is going to occupy 24 decimeters cubed, right? And therefore we can say that therefore the volume of NO is going to be 24 multiplied by the moles of NO, which we've worked out here, right? So it's 24 times 2.72588824, right? And that, if you work that out, that's going to give 65.42 11776, right? And that's going to be in decimeters cubed, right? And in this case, we have been specifically asked that our answer needs to be given to a maximum of 2 decimal places. So I'm going to work on rounding this to 2 decimal places. So as you can see, this would be rounded down, right? So it would be equal to 65.42 literally, so rounded down, and that's going to be in decimeters cubed, right? And we can say that that's the 2 I'm thinking ahead of, that's going to be just 2 decimal places, all right?